Nice. I'm gonna send you. Should I send you the video? Who's gonna send it to us? To start it.
Yeah, some of us are not here, so.
Yeah, I'm recording. So.
I'm gonna send you.
Also because the document MPC sent has overlap text from the different document. We have to correct that.
这是今天喝的第一口。啊，拜拜。
Okay. We're getting there. Sorry, always takes quite some time. Okay, guys, you ready? Sorry that I'm so late today, couldn't make it earlier. Did you do the exercises? I've seen some people have uploaded it, not everyone. Please do that. I've had a short look, looks pretty good who uploaded it. So how did it go? Did you have like trouble with it, or was it doable? You had, but
Yeah.
you could finish it, or you?
I finished that. I was asking you, you said about the visualizers.
Perfect.
About that. Okay.
But
That's how I finished it.
You got it to run everything.
Yeah.
That's good already. Perfect. So to be honest, we didn't get as far as I. Sure.
So import.os, what does OS mean?
Operation system. So that's if you want to save data, if you want to use anything which is like related to folders, you're gonna need that. So
anything related to the Poland on my computer.
Yeah, I mean, so Colab is not your computer, right? Colab is online
Yeah.
and is a Linux-driven computer which Google gives you. But even if you want to access that, you're still gonna need OS. Yeah.
And one more thing, can you explain again what was the PIL?
PIF.
The PIL.
PIL.
Yeah.
So this is a package like you, as we did last time, you can import packages or like other additions to Python, and this is one to work with images. So you can work with images. There are several add-ons, but PLI is one of the most common ones. It's called Pillow, actually, the full name. So,
Okay. Thank you.
okay, so today we don't start with a presentation as usual, but we start with code directly, because actually it's what we last time I didn't get as far as I wanted, so we just like continue there, and then we do a presentation or like a theory topic in between, and then we do an inference with an AI, and next time we train one. It's kind of the schedule. So yeah, so please open a new Colab as you are used to it already. So you just need to open Slack quickly. I can share the stuff with you guys.
Don't tell.
So last time at the very end, I showed you a data set where which we're gonna use this time, right? Just a picture of it. So that's basically what we gonna do now. So first thing, we need to install some packages, and I just copy you some code. You can just copy in yours too. And I copy it in the folder. So these 2 lines.
Sorry, what's your screen?
Ah, sorry. I copied it. I can also copy it there, but then you wait. I copied it in Slack. You got it in Slack. So just copy paste it. So this is just these 2 packages. One is to work with geometry, and one is to work with shapes. So anything like rectangles, circles, whatever. But we all know used to, and then you can just install. We're gonna need those to work with the dataset, because the dataset is not images, it's basically geometry saved in a certain format for Python. So it's gonna take a while because it's downloading. Just copy paste it. I can zoom also, of course. But I also I copy pasted the code in Slack open. This, I think you're used to it. Like, this is stuff you don't need to necessarily know. I also don't know that. Like, the stuff you need to find out then. Okay, and now we need to import some more things. We can write that, but it's also import warnings, so we can utilize, that it tells us certain things we shouldn't do like that. And then from Shapely is one of the packages we imported, right? And this is stuff, actually, I also just copied this stuff because we use packages that don't work together so well eventually. So we just I will just send it to you as well, basically. So the first thing we wrote, and then also paste the lower part. Oh, and one last thing I completely forgot. Sorry, just need to get something sorted. So, okay. Sorry, back to work. I just invited Cesar to the meeting. Okay, so that's what I just sent you. You can also just paste it, and then we just run it. And seems like I have a typing mistake. Let's just copy it. No. The previous installing was wrong. Okay. Yeah. Okay. And then now, so basically this is, we installed packages. So a lot of packages are standard installed on that, on Colab. Some we have to install ourselves. So what we did with the pip is that we install packages additionally. You can also do that if you run into something you don't have, you can install it additionally. And now we need to import a lot. So some of them we've seen before, some of them we didn't, but I can explain each of them very shortly what they do. I'm not even sure if we need all, but didn't check that. It's just like if you start a Python code, normally you just start like importing a lot you may need, because then you don't really later have to take care of that. Yeah, for enumerate. I think seems like I have a spelling mistake there. This one we all know, right?
You wrote in all pandas DE twice.
Doesn't matter what it is. For whom it is too quick, I'm gonna also copy it, but it's good to also just type, to be honest. It helps to be quicker with it. And then the package you just asked will import image. Okay. And this is what I just wrote. That's what it runs. So very quickly, this is another package to work with images similar to Pill. This is Pandas we used before, which is the one working with table data like Excel. Pickle is one to compress data. JSON, someone knows what a JSON is eventually, is kind of way of saving a text file. NumPy is also we work with it, is like saving for tensors, and GeoPandas, Shapely, all of these are for geometry, which we're gonna use now. And Matplotlib, yeah, for showing images, right? It's also an image library. So there's several of that some have certain things, others can't do. So it's a little bit, yeah, confusing with Python sometimes. JSON? And JSON is like, I can just show you quickly what JSON is. They look like this. Is to save data. It's like, it's kind of a class. You remember there's a concept, but it's a different kind of data format, kind of. Okay, and now we do like last time, we connect to our Google Colab. So we mount it. So just gonna ask us if we want to connect to our drive. We just accept that. Did this last time as well. And then also as last time, we're gonna see our stuff popping up here, hopefully. Right, so we have our notch. And then last time I shared with you already a folder with data. Do you remember that there were 3 things inside? We only used 1. You still have that? Can you find it? Like, so we did also last time, we did like our path to it. So can you localize it on your folder wherever there's, drive, and then your. So there was one. I just copy where mine is. Yeah, the planified pickle, if you can localize that. It's not going to be the same path, it must be on your drive.
How do you do that?
This, I just copy pasted it, so I from my own operation. But you need to find basically it's like a folder, right? Like you. So you saved all of you? I hope saved last time. But I shared. Can share the link to the folder again as well.
No, if it's on the Google Drive,
It's on the Google Drive.
then
So
do we need to type entire thing, or you can just copy paste from the Google Drive?
you need to find the. So it needs to be in your Google Drive, not mine.
This one.
And then you need to find the path to it. So it's like in a folder on your computer, content, drive, my drive. In my case, it's here, but everything after my drive may vary.
So do we need to type it here, or do we need to type it manually?
I think you need to type it. I never found where you can copy it from Google. It's a little bit annoying, but I think you can't.
That's fine. I saw.
If it has the ending, so we need, this is like this file needs to be somewhere in the, wait, I share the link again also to make sure
Oh,
everyone
it
has
needs
it.
to be the file instead of just the
Hmm?
folder. It needs to be the file.
The file, it needs the file specification. So the planify.pickle is the file. This is the file. And if you need it again, that was where it is. And then before we run it, so we soon gonna find out if you found it. Otherwise, we just shortly debug it together.
It's fine.
It's been, okay, how do you do this?
You type this.
Yeah.
Don't plan it.
You need to find the path. You know, it's like same as on your local machine. You have like the folder structure. You can also in the top window of your local. You know, like this basically, like this window, and this is the path. And you also have this in your Google Drive. And it's just the same as here, and you just like type the name of the folder. So if when there's a folder and a folder and a folder, just you append it to the path.
I can,
You need to copy it to your own, I think. So now, and this one, we just import this pickle file, which is like a compressed file. It's similar to SNP somehow.
if every time I download the file, it's a zip file, so I have to extract it, right?
In this case, so because the ending is a pickle, right? So this is a certain kind of file type. It's a compressed file for Python. So it's a very large data set, like 10,000 geometry. It's like 10,000 very small Rhino files if you want. So that's a lot of data. We compress it. That's why we pickle it. Pickling is like, you know, pickled cucumbers. It's like that. So just make it smaller.
Extract the document.
That's what we're gonna do now. We extract it, but you just copy it, the file, and find the. If you download it on your machine, it's a zip. Then you have to extract it.
Okay.
Sorry for that. I didn't get that.
No, it's okay.
So this one, last time we did this very shortly at the end. This is like a data table, and this is now gonna import that data table as well. Let's see if it runs. It's gonna take a while because it's quite large. You probably have not the right path. Did you try to run it? So as you can see, mine also is quite slow, and this is loud. Because we basically downloaded, right? Actually, I think it's more, yeah, mine work. I think it's not that huge. It's more like the internet is slow. think mine is done. Okay, did it work for everyone? Okay, so now, as last time, we don't know what the data is, right? So we just look into it. And columns, so you remember it's like an Excel file, right? Like it's a lot, it's like a kind of like a table, that's how they. So if we give end columns, we see everything which is in there. So we have like which level it is, which yeah, what's the index of it? It's not that important, but like, and what is included, pool, garden, parking, and so on and so on. So it's kind of like a data structure for a plan, basically. And then also just to get a little bit like exposure to it, we're just gonna look how long it is. We can also just do that with length like this. So yeah, 10,476 data points. So it's basically 10,476 floor plan. And then also, for example, we have like one of it is the size, right? Is yours not working?
Oh, it's because it's still extracting all the.
Okay, but you can still just type it. So we can also, for example, choose one of these columns. So we're gonna look at size now, for example, which is here, right? So let's see what's in there basically. So we can do this, which is our data table, and then it's a similar access to it as we are used from tensors, right? So we just do first size, then all of it, and then this is the the first item. So 0 is like the first item of our list, right? We count with 0, start counting with 0 from everything which is inside size, and then we specify size. So we can run that and have a look. Okay, so that's the total size of the bounding box of the plan, for example. This stuff, also, if you get a pickle data like that or any like kind of data, you don't know that. Normally they have documentation, hopefully not always, but or you just like try and look what you get out of it, right?
For this size, semicolon, like size colon and 0.
This one or this?
All like this line.
So TF is it's for data frame, it's sensitive, right? The size we access. So imagine it like a big table, you know, like an Excel table. And size is the name of the column. So it's like, wait, I just show you a picture of an Excel quickly or open an Excel file. Give me a sec. You know what? No, I show you in code. It's probably better. I hope it works. Yes. So df.head 10, or I could also just do 2, gives me the first, now the first 2 items. Before it was the first 10. I can also do, what was it? So sample, I think, gives me random ones. So this is gonna give me 2 random of the whole. Okay, and now look, so with the size, I access the size part. So it's here the column size. I don't know where it is. I think it's hidden because it's too large. And then inside the size, there can be more than one item, right? So here's a multi-polygon. This, for example, the level is just one number at the index or the level, but then sometimes it's also a list. So at first I access the size, then I access and I say everything in size, like the whole list. And then this is like from which row. So from the zeros. So if I do again head instead of sample, this would be the zeros and then size, which is unfortunately somewhere hidden here. But if I put, for example, if I would do, let's say bedroom, I don't know. I get that as well. And I think it shows me even the polygon. No, so it prints which is here. Okay.
Because we have to know all the elements inside the.
Sorry, how was it?
This, we need to know all the elements inside the chart.
The thing is, we don't need all of the data information, but eventually if you would want to do something else with it, you extract more. I also show that for you because if you, like, for example, on your projects or for like at the end of our class, we do an exercise, and if you want to work with data you created yourself, you need to bring it somehow from Grasshopper to Colab or wherever you use Python, but if I give it to you in Colab, probably then you could use this kind of transportation or however you want to call it. There's several, but this one is quite intuitive. So yeah, and Reaches is just also, I want to get you used to like work with large data sets because it's a big part of training machine learning models. Okay. Okay. Yeah. Similar what we just did. We can just slice off a part of it. For example, we do size, not sizes. And then all. So now I take all sizes from the whole thing and I put it in a new variable, right? Like sizes here. And then I want to get like the min and the max of it. Just gives me some more information about the data set. So this is the smallest floor plan we have. This is the largest. It's a little bit difficult to say what exactly these numbers are because we don't have a scale for it, but it's the locally chosen scale. And now we're gonna visually look at it. So just an example, we use bedroom, and then this is one of our extensions we installed, otherwise it wouldn't work. So now we're gonna print or show all bedrooms in the zeros thing. So this is basically, if we go here, sorry, go back, bedroom, this polygon, and this is now like it has the edges saved, the color, everything. So, and then we can visualize it. This one. So this is again, this is head, and there's also sample, which gives you random voice if you do this instead. Now, just example wise, we look just at something, one of the other things. Let's say. Sounds like I have a typo. Yeah, it's walnut walls. Yeah, so this is all the outline walls of the theories.
Can you check the map? Bedroom.
You need the geoms. Geoms. This is one of our geometries. This is one of our packages we have installed. Otherwise, we couldn't utilize it, and otherwise we couldn't see it also.
Very good question. What does head mean? What then few steps?
It's like head. You mean, well, like the head of the data. So if you go from the top, just how they describe.
Okay.
Yeah, it's just syntax. This stuff, like someone else wrote that at some point. They chose how to name that, and we just accepted and used it. This is like that kind of. And in the best case, what they wrote makes sense. In the worst case, it's hard to understand.
Okay.
Do you all have it? Do you work?
After I explain this, this track. It's like possible.
Can you explain? Yeah, you're missing.
Oh,
You did run it.
For junction.
Probably these two, the probably if you have this kind of tick, I don't know what's the name of that again. But if this is like three, that's so random. And also it's like and here it's missing, so you didn't run these. In this one as well. Wait for other I copied it in there somewhere. Yeah, there's a dot. Yeah.
There.
Yeah.
No.
So, yeah. No. Something like, I don't know what, but can't find it. Do you have another folder in between?
No. Like my drive.
然后在这里都显示了有
Then
带颜色的，我看是紫色的，
就什么时候这个
对，
就是这个紫色的号是号拉分号什么意思？
我的
号分号。
这个
But what we done is your, just like your main drive.
在详细在这个可以解释非常清楚。比如说在这个拍摄里面，用保存出那个这个。
Can you click on it?
我们这已经问过了。
They say that I have to download it because there's no preview.
In the right.
It says open with preview.
Somewhere like more information.
Details.
I don't know which one. Can you maybe move it in another subfolder and then try it?
I'll try that.
没有办法吗？晚上。
Okay, so, but we now, for everyone else it worked, everyone else is there. So now we want to see the whole thing, right? Like we would like to see the whole floor plan. So in theory, we hope this works. I already spoiled it, it doesn't. Right, that would be reasonable because we think like show us the whole, all of the lines from 0 and then all the geoms like, so, but that's not gonna work. So we unfortunately need to write a little bit extra stuff. It's just not, the syntax is not correct. We cannot reference a dictionary, which is the first like that. So yeah. So what we're gonna do, and anyways, because we need it, this is just a, it's not an image, it's just a way of showing it here. So we need to transform it in images for what we want to do afterwards. So we're gonna write a function first to create a polygon from it, or like to show multiple polygons, basically. So function, right? Def. Sorry, I shouldn't do that. I'm not sure if we used that before. Do you know this? So this is type specification. So normally we'd never say in Python what is a type, like what type we are using, right? But we can do it. So if we do, this is the name of the variable we give in. If we do these two dots and then in this case list, or it could be int, or it could be whatever, like all the types we have, right? And then that should like give us a specific type. So in our case, it's list. And then it tells me, so if you try to pass in something which is not a list, it's gonna give you an error, which can be useful because sometimes you don't know. So you can specify things that can be given. And now I think we also didn't do that before. Let's see. You can also give like standard values. So now if I would print, if I would not give, like only give one variable, so I can show you. Passes, by the way, is also just a keyword that says the function does nothing. It's just a little thing. So now we could do this and do. So this needs to be a list. I didn't run it, right? So won't do anything. So it works, right? But if this is a 10, it hopefully gives an error. No, it also works. Okay, I did specify it well. So it didn't use. But you can read it now. Like there's another way of specifying that it crashes, but now it tells me at least it wants a list. Right? You can see here it wants a list. And then I can but you saw like I specified 2 here. Well, and I just gave in 1 and it didn't crash because if I don't give in the second, it's gonna use these values. That's basically it. Not sometimes very useful. Okay, but we are up to something else. So this is probably just code alone. I tried to explain it, but it's not super important that it's kind of in depth. We just need that function basically. Yes, is instant. It's one word. It's a function from a package we imported earlier.
It's instance.
Is instance, yeah. So this is basically if there's several, it tells us P is a variable. Honestly, it's a little bit complex code. I should have probably written it easier. Basically, what this does is iterating over all the things we're gonna give in and then like give all of them back if they are not empty, if they are an instance. So it iterates over all multi-polygons and returns the shape if there is one. But probably better just like code it and you're gonna see what it does in a second. And also, honestly, you don't. Python is a language which is very like tempting to probably shouldn't tell you, but it's sometimes okay to use code from other people you don't understand if you understand what it does. You don't need to know like every single line of it, but if you know what it does in general, it's fine to use it, you know, because then it's programming is like that's easy to copy, easy to share. You can share it together. Just don't copy everything, but it's part of it. Although for your homework or like for your large task, you need to specify what you wrote and what we copied from somewhere else. You need to comment it in, but just later. I'm gonna say that again. So basically, very quickly, it's like we give in a multi-polygon, which is one of those. It's called a multi-polygon, or this as well, right? Because it's multiple polygons. And then we iterate over it. If it has an instance, we add it. And then we plot it with matplotlib. We convert it to an image. What happens here? Plot color green, alpha is how transparent it is. And then we set a resolution and we can plot it. So the plot transfers it into a plottable image. Basically what this will do. And then sorry. So here, just choose, this is like index, it's a short, it's my name, 0, that could be anything. And then we choose from the, like the first part in our data, we use the column called inner, what we did before. And then, I don't know, can do also bedrooms. Basically, so use this, just so we just like use these two and then we can put them into a list and then we can use our function we did ourselves, right? And then put in, we need to make a new list of it, but inner bedrooms. And then that should work. We run this, run this. Nope, it doesn't. Thank you. No, that should be fine.
And bedrooms after the bedrooms.
But here also for bedrooms, so that should be not a problem.
No, but next to it.
Yeah, but that should. I don't know. Okay, I'll Google it quickly.
Perfect.
Yes.
Maybe start. I probably forgot to import anything.
Because annotation means.
Oh yeah, that's possible.
No, it worked, but
It worked for you.
yeah, but it was because I needed to download the file to my computer. Do I need to do that every time?
No, I don't think so. If it's in your file, it should work.
Well, I downloaded it in my computer and now it works.
But then upload it again.
No, I didn't upload it again. I just downloaded it in my computer.
But that It's still because you reference it from
The
Drive, so
That's the only thing I.
I don't know that. Honestly, I don't know why this doesn't work. Okay, there must be a spelling mistake. I didn't find it, to be honest. So you also have it probably then. Because I just copied it from my other code and it worked, so there must be somewhere here is a typo. Ah, yes. So typical. This needs to be a capital Geoserious. Yeah. It's the joy of programming.
No, the error is still there.
Is it? What does it say? Mine is also.
It's working, but it's not really working.
Can you scroll up? I know why, probably because you.
最后一步我看过3个 New Series 那个 S。
I think you scroll up a bit. Because this there's with QS and this is only one. It's also a small typo. This one. Look, there's also the hints to. This is wrong. It's not referencing because this needs to be the same
Resolution.
No, just the same variable as it is up there. So it's the same spelling, and there's 2S in the front and the bottom.
前面写错，
So you have this only
前面的
Is it working?
the last one. Yes.
The last one. So my error was when you type along correctly, you have the same one. This one, this S or small needs to be large, like capital.
这一行
It needs to be capital. How is it? Then you have another spelling. Or what does it tell you?
The last one.
Yeah, but it's did you run it again? If you yeah, if you change something, you need to rerun it. Otherwise, it doesn't. Yeah, but then
你前面第3步你跟我说那把
so first you need to make this capital.
最开始
Use
不是第3步
this one same as mine.
PIT 3
The S here.
最上面是这个分号
Just
Ah, the S.
他不知道
and then this one is also you have to like it's not the same. So you have to just it needs to be the spelling. Just you can just copy it and place it down. This one above.
我考的
No. In this
Here,
and this needs to be the same as this.
as this.
Yeah, there must be a small difference. But to avoid it, you can just copy it. Now run it. And then run this. No, the one in each. Yeah.
这个
There's a character just you
This one won't work.
This perfect. can delete it. It's just an example I
你
showed.
真的是跑了第一步，然后得把第一步中所有东西全部一个。
And I think you
你第一步确定那个 KIP 那里没有写
in the import.
这是麻烦。
有刚后写的，后写的就不错。
Also, I sent you in Slack.
你看一些文件，我看不到那什么 PIP 的吗？
And for
这
you,
场号13嘛。
对，我是不用。
Why?
this one, I don't know. There's this yellow boxes at the bottom. Is it like at the top? This one. You delete those. I don't know what it is, but that might be probably the problem. Maybe it's like from your channel. I don't know what's your.
对，挺好，挺好。你那边从那个 DM 后面，它上面都已经改完了嘛，对吧？从 DM 后面的 DM 后，从这个后面，从这个后面，你看它可能是这个在跑，你说
哦，微信的那个空格。
Okay.
非常的绝对不能是。
你看你先那个打个打的，跟我一样。
跑它下面。
So one question, I'm curious if someone knows how we can do that. How, if we would want to add another room now on this drawing, how would we do that?
Yeah.
So yeah, can you try doing it? So, and remember, just to the drawing, add one more room. And then you know that you remember that we looked at the very beginning. We showed us all columns, right? So you can just choose one of those. We can just write this again as well. df dot columns. So this is our columns. You can just take one. If you want to look it up again, df dot columns, right?
This example.
Have a look. So you guys got it?
Yes.
Is this working?
I got the window.
Perfect. I didn't solve it yet.
Just this, it's one slide, doesn't definitely. If I copy the, I think that
Can you just rerun it? Like the whole thing?
yeah, I rewrite it on different, which I think is not even, I don't know. Move your bump and just be like. You can do it. Brilliant.
It's like, it's not a point. Look,
There you go.
this is how it spells like a underscore.
Okay, yeah. Like the body.
Basically, it's because this is a variable. So this is a variable. We assign something here. You cannot split the variable with a point or dot because then it thinks it's like a function. It's like a class or variable you call something on, you can't do it. So you cannot name it with a point in between. That's
What is X as where as?
I don't know. Not everything is a polygon though. I didn't run this. Okay, so worked, right?
Good.
You got it?
Yeah.
So yeah, perfect. Now what we're gonna do, and I just copied that for you because, or you actually, now we can do it different. So now we're gonna need to show everything we want to show. We need a list with containing all of that, right? So we just do a variable. We call that geoms columns, and then we do a list with strings of all of the things we want. So basically we want all of the till here probably. Did you see that? So we can just get from the DF columns, and then we just so because index, yeah, I know that, but we had before we did the head thing, right? So we know not all of that is multi-polygons. We only want the multi-polygons one, so we do a list with all the names of all the columns which are multi-polygons. You can just copy it, I think, from pool till inner till here, and then put it here, run it.
Did you copy that list?
Oh. Control C, Control V. Or if you have an Apple, I have different. Okay, and now we try to visualize the whole thing. And now bear with me. It's gonna be a lot of code now. So we need another. And I'm gonna also copy you some of it because don't need to write all of it. So this is, yeah, just choose any number. This could be different. So nice type. Okay, so this is basically that gives us or will give us a list like a length of numbers at the same. So distinctipy gives us a different numbers in a length at the same length as these rooms, and we multiply it by 255.
Is it U or U?
Uint, integer. It's like a data type.
Oh,
But this is just, I guess it's better we just accepted the syntax. So what this will do is give me like a list of, so it gives me for each of the rooms a dictionary with a color and a number, so I can always have the same colors for each rooms because not every floor plan gonna have all of the rooms, right? So then we always have the same number for it. So I can also, this one I can copy, I guess. So it gives me an array from NumPy with colors, and I multiplied by 255. Does anyone has an idea why? We talked about it eventually. Yeah, exactly, because it gives me a range from 0 to 1, but if I multiply it with 255, I get it to the range from 0 to 255. Very good.
Error.
From this, probably from this, I just copied it for in your Slack. No module for what? Distinctipy. So you need this is the thing you need. First, you pip installs it, and then we reference it. Pip install Distinctify, import Distinctify. And then there you also need to say. So next thing, we're gonna do. This is just a very short function to show an image. We're gonna use it later. Just code along. So this is one to show an image is similar to what we did last time, but not with matplotlib. And this just says, so if image needs to be a numpy and it needs to be an integer, so a full number between, we did that last time with tensor with PyTorch, right? But it's the same principle. It needs to be full numbers. You cannot have a floating point number like one with a decimal number, which is cannot be a pixel. So we just say that we put an image, we make sure it's a U, and then if it's we make sure it's an int or convert it to it, and if it is, we display it. That's all that. So and then we okay, perfect. Okay, and now we write one to get the full, like all the things, full plan with different colors. So we get the whole plan with different colors from all the columns we chose as an image. So that's what we, now it's going to be a very large function, and I try to use the im show. This one. Maybe there's this. Did you invent it? Just check. It's just a guess. So I guess because it's kind of, it's a little bit far away from there, right? So, but this needs to be also indented to be part of the. Ooh, actually, I think just one. Yes. No, 2 times. Yeah, 2 times because of the other except. Yes, 2. Yeah. Needs to be in line with this. Does it? Yeah, 2 times. Probably there's a typo though. If it just still doesn't work. Because indentation wouldn't throw an error, actually. Indentation only throws errors if you run it. If you just do that, it won't. Okay, we do the other ones before, I guess. Should have shortened that maybe. Okay, now Shapely is one of the things to work with these geometries we've seen before. We imported again. Maybe I think we've imported it before. Whatever, let's make sure. And now we just write functions. I think we only write the scaling one when I copy for you. Okay, we write functions to transfer it, transpose it to things with it. So the very simple thing, we just wanna rotate our geometries, right? So we give in the polygons, that's what we want to rotate. How much we scale it, sorry, we don't rotate it. How much we scale it in the x direction, y direction, and then which is the origin point, right? It's like all operations we all know from our drawing softwares.
Yes.
So if it has polygons, we return it. If it doesn't, it returns the same thing. So this is if else thing, we did that, right? So we're gonna have a new this is a little bit a tricky thing, but it's very cool about Python. I can explain it in a second. Polygons. So this is a for loop in a very short, it's a for loop in one line, basically. You remember for loops, right? So, and then additionally to that, we apply, so we iterate for each polygon in polygons. We give in polygons, right? And then we go over each polygon, and then we perform a function, and actually we perform the same method function we wrote, which is, so you can call the function you are in from within that one. So you can do like a kind of in like a several, there's a name for that shit. So you can call it several times, even in a loop. Like you can recall it until something is done. That's why you do the for loop. And that's what we can do here. And we can also this for the one line for loop. So you could also add it to a list something here, for example, but we just apply it and then we directly return. Basically, the only thing it does is for all of the things, like all of the geometries in our polygons, it's gonna rotate it, even if it's a list. So yeah. And here, this is the actual scale factor. And direction we need, and that's it. And the last else. So again, in this one, if it's only if it's a list of a list, we're gonna put it into a normal list and return it. If it's a single instance, we rotate it, and if it's in any other case, we just like give out what we put in. Okay, somehow understood. So if it's if it's a list of polygons, so like we can pack them into each other, then we first go over each element in there, like each list, and then perform that again. So we still gonna rotate all of it. If we don't, if it's just a single polygon or just we directly scale it, and if else in any other case, which is very unlikely, we just return what we gave in basically. Okay. And now we're gonna, because we need it for the next function, I copied the other two. We're also gonna do rotate and translate. So rotate and move to scale, and there, but the structure is the same. I'm gonna give it all to you.
Oh, where?
I need to Google what's the name of the if you recursive, it's called a recursive function. Sorry, it's the vocabulary I didn't have. I posted it also, right?
It's very recursive.
Sorry,
How to spell recursive?
what it means, or
Yeah.
recursive. S-I-V-E. Recursive without the L. Recursive, like
Sorry.
okay.
I'm trying to figure why I don't have the back. Don't worry.
Okay, let's continue. You guys ready?
Like, why do you think the job?
So now we're gonna do a small function to get the full plan. So we can augment it, we can flip it, rotate it, and also get the whole image. So it's a little bit a longer one. So let's continue with that. So first we give the row which we want it from, the width is the size of it, and then so the row from our like list of plans, right? And then if we wanna rotate it the degree, and if we wanna flip it, and flip is standard false. lip is like mirror. So first we copy the row we give in just to make sure that we don't like augment the data in the data frame, but instead have it safely. And then we have this, what we used before, inner is like kind of the outline of the whole thing. This is called inner. So like this just a row called inner is the whole object is specific to that data, right? So but we just used it, and we need the centroid from that because like the biggest thing to rotate it using that centroid. So we do that. So this is if the degree is given. So if it's not 0, we're gonna rotate it first. It's basically everything we do. And I think I have an n too much here. Okay. Then we take. By the way, if you write code yourself, commenting is always a good thing. I do it actually way too little for that, to be honest. So now we get the centroid again. I don't know why. Yeah, we don't need that actually. Yeah, I think you can. Yeah, better leave it in irony. So what's also a problem with our floor plans is they are all different size and they're different at different places in space. We don't really know where they're in space. So when we export them as an image, we're gonna find the bounding box of each of them, which we're doing here. Inner.bounds is like the bounding box, and this is gives me the information of that. So then I can place the image kind of on top of that. And then the total width and height. So yeah, this is makes sense, right? Because we just, if we want to have the min and the max size of it, we can just like subtract the minimal and maximal. Like this, I hope.
X max.
This is missed. So it must be like this. First the 2 min and then the 2 max. Also X max. Okay. And now we need to know which is the larger of the two to decide. So imagine we have like our floor plan is like an object, and then we want to make a window which is exactly going like around it. So we need to find out which is the larger size so we can like make a square window around that. So that's what we're doing next. So the width is smaller than the height. The larger diameter is the width. Because we want square images, that's maybe important to say, otherwise that doesn't make sense. So this is basically the center point. So it's not, you don't need to go into this too in depth, just probably just code it along, but it's very simple math basically, right? It's just a square. So if I want to get the center, I just divide it by 2 and add the half of the other side. And then if it's the other way around, so if the height is larger than the width, we do the opposite basically, right? So we can basically copy this, just switch it. It's -1, I hope. So this is basically the center of our bounding box we calculate here. Now we move each of our geometry objects to that center of the bounding box we take the picture from. So each columns and Guillaume's columns. So we iterate over all of them. We can move it. That's what we also coded before, right? Translate, or we didn't code it, we only coded the scale, but it's one of those. Yep, not affinity, only translate. So this function, right, this is one from those. We're just gonna utilize it here. And now we scale it that it fits in our bounding, our image frame, basically. Column. And now almost the last thing. If we flip it, we also need to do that, right? So flipping is basically scaling with a negative value, right? So in our case, the x, so we just do that. So we do again, which the object we use, and then -1, 1. So one of the scale, x scale, y scale stays the same, x scale is -1 flipping, right? And this is the bounding size, I think, actually. Yeah, this is the size we also gave that in at the beginning. So this is the total, like the whole size of the image.
Why don't we with the line might be two
So
in the wrong structure?
because look, if we go up. So this is the coordinate of the center, because our bounding box, right? If you divide it by 2, it's the center, like the total length is center, and then the other one is also the center. But yeah, this is, by the way, this is all transformations. In theory, you could also do that on your geometry in Python. You can write code like that, right? You just like Grasshopper written out if you want. So for what you do with your transformations, we're gonna like go more in depth. You can. It's a different syntax because it's Rhino. We're not using Rhino, but in theory, you can do stuff like that. Like we have 10,000 things now, and we always do the same operation. It's a general thing we do on that, right? Okay. And now we just define what we are changing to return it. And this is the same thing, right? Because we have now a square thing. We have a square. We're gonna always give back the width also for the height. And this one is because we have so our wall width, it's more like a thickness of a line. So we also have to adapt that because we scaled our floor plan to fit that, like our pixel sizes. I think it's quite complex to see it like that, but it's not, you don't need to understand all of it. It's mainly needed to use it. Okay, hopefully it works.
With this,
Perfect.
and the B and H are.
Yeah, awesome. Thank you. Probably I also have a mistake. I wouldn't be surprised. It's a very long thing. Did you run it already? No. On what did you run it?
This int object is not callable.
Okay, and now what we are going to do, that's where it becomes even more generic. So this is basically, we wrote the transformation now for all, like that it works on all different sizes of floor plans we have, right? And by the way, so wait, I give you, we never looked at it, I think. So if I just do, I don't know, different thing here, something else comes out here, right? Like I change the index, I get different floor plans. I just give you a little bit a hint how different they are, right? So we're gonna go, you can change the index here, right? And then it's gonna show you one of the other floor plans. So now we're gonna go over all of them and do the same operation then. And this now, so basically, this is also a quite specific thing. So this is our method, right? What we defined here. And then afterwards, we give in the other two things. And then we apply for each row, like each row in the whole thing, we're gonna apply that. It's very different, right? Normally, we call a function like this. We would call get plan. You can also do it on the first one, right? For example, df and then 0. And we would call it like this and then with 200 or 500. But now, like this, we call it on the whole floor plan at once. And this one we also so probably, yeah, I need to index like we did before with the list, right? But doesn't matter, we just run it for the whole thing. This is what we're doing here. So that's gonna take quite a while. And I have, of course, a mistake. So let's see on which line 7. Okay. See, yeah. So debugging, right? Also tells you which line you have to look for. Line 7 in my case. Oh, it's somewhere else too. So, oh, it doesn't help me. So there's a spelling mistake here, that's for sure. But where? Good luck. Oh, these are swapped. Okay, in my code, these are swapped. That's for sure. It's the one mistake for sure. This one, the last two were swapped. Oh, this is also, these needs to be swapped, these two. In the second, in the else, these two were swapped. Just and this. And I hope everything else works. Yep. It's in the scale function. That's the problem. So it's here. Yeah, here. So this needs to be like factor instead of phase. I'm gonna copy it also again. So yeah. Actually told me that. I was just so stupid to read it correctly, right? So it tells me it's in the line 7 in the other box. But an unexpected keyword argument X phase. So this one. And here as well, as I just see, so both just typo mistakes. So both it needs to be factor.
I read when he said that and I thought it was like on purpose.
No. Unfortunately not. Okay, let's try. Yeah, it works. And that's gonna take quite a while because now we go over 10,000 floor plans and do these operations, right? Did you try to run it? Yeah, of course.
It's not defined. 我这个能没地方吗？这个分析在哪儿？下个地方25，哪个是第25行啊？因为没见过。
It's you see the other thing, so you can touch it.
I don't know, it's just,
And you should,
you know,
and then your mouse is in that line where you are.
yes.
And there it tells you. Because it's spelling mistake. But that's like if you
What
run
do
it,
you
so.
It keeps going.
There's never like, but it helps you walk. The first one is not. So from that, it's like, in there, it's like a class of. It's.
你这儿写错了，对，比较注意。
你把上面改了就行了。那我不是得从这儿开始推进你吗？
可是这什么？你下面写的都一样吗？
那我得全点一个，是不是？
这个，哎，这个已经。
How do I get, because it's not like it's still run, but not correct. It doesn't tell you where this was. Yeah. Yeah, probably not the same thing because we have this one. And I struggle looking. Yeah, there was whatever. This is there is only for the family. You're jumping and you're even jumping in the line and the mistake is worth the thing. And then
根本就会在这一块买，我发现写的这个感觉，他说拆开根本就没有生写的这个 correction is always drawing in picture the true you know, so. So, if I say this feel very good. When the face 变成 fat，每都变成 face 了，like there is called find things and not
超过最大递归深度，
the last part.
超过最大递归深
And
度。
then then you get just but then of the
第三行 return，
after you yeah, control there because that's your variable, but
这个在哪里看到？
so you know you assign something here you call something from inner and then you get information that's central of inner. And this one you can call however you want to later call it correctly. But this one you can't because it's someone else defines what central is.
这
And this one I just my mistake, you just X
是我这个
aber dann ist
我打的东西。
I already.
okay. But just it's a one not so
这个
the
不是这个，不是这个，
is
这个玻璃上 sorry。哎，
Will it work for everyone?
no no，
No, no, no. Sounds like
I'm still looking for which role is this?
you can keep talking. You can click on this. Then you jump to that. So it's there, yeah. And probably it's just other mistake I also did. So here fact it means I think this needs to be this one. So I know what's the mistake I did right. Can you go right? So mistakes. Yeah. Can you see the error? This one is that's strange. If that's a problem, we should all have that. Can you show me again? There must be a syntax error. The other side. Right, I show you in this one. We can compare. So it's scale, right? So this one. Wrong. Wait.
I missed the first one.
I know. Yeah. You have a wrong. I don't know. No, that's not that. You copy it from the. Just try to copy it. I currently don't remember the.
Oh, no, it's better.
I put it on the same.
I didn't.
I didn't give it a separate one.
This one.
This one, this line, but then this one, this one.
今天学的都能用。今天这个学都是
Yes.
There is I just think it's probably the large function as well. Yeah, make sure that everyone has it. There's one because I also made a mistake. Like it's failed again. So I think is look at this part.
Here. It has an X.
Is the upper one the upper might should be.
So I share with you the thing, the code that we wrote so far. So you have it already for reference.
You're gonna send the last one?
Yeah, I'm gonna send this to the group. So it's just all in the same level. I don't know where it is too. Does it work for most of you? Yeah. Okay, I sent the last, if I find it, I sent you the latest collab I have. I wrote and then we continued. I didn't. I think I didn't send it yet. I need to put it in the right
Okay, it
way.
wasn't over. RC10 deep learning. Yeah. I think it's so it should be in your general folder. It's two folders, right? The data one and the other one in the main one. Okay. You find it? No, on Slack,
It's in not on Slack, it's on
the folder.
yeah. Oh, it didn't start me fast. Okay, now we gotta write now to show that image, something to show that. So we again do a definition.
But if it is not working, I still could.
I shared my latest card. If you go to your not there in the drive folder.
Oh.
I shared the drive. I have 2 drive folders I share with you, right? One is the one where we have like data stuff, and the other one is just where you upload the exercises, all of that. And in this one there should be one called, I don't know, code along halfway or something like that. I share a link again. Wait a second. So this one is where we are. And please copy it, because otherwise, so copy to your own drive, because otherwise you, yeah, as usual, you just code in that one.
Copy all of them?
No, only the one.
Oh, here.
You can also just copy the whole notebook. You can click on the notebook somewhere where it says like, I don't know, file probably, and then copy to your drive or something like that.
It's on the halfway thing.
Yeah, this one. Okay, does anyone has a running one now? Like either copied the one I gave you or has yourself, which is working? Okay, let's go on. So next definition, that's like masking our shapes to make it into images. So we put in one of the geometries, we transfer it to a NumPy, we make a NumPy arrow in the size of the image we want, and then we create a polygon from it. And then for each of these polygons, we color the pixels which are inside of that polygon. Basically what we're doing. So we iterate over all of our polygons. And then we use CV2, what we is another package with images.
The copy one still not.
The copied one is not working. You need to run everything above. So if you start a new collab, I think if you start a new collab, you basically connect to a computer which is hosted by Google somewhere, and they lend you space, but then you have to run it before, like, the code is not executed yet. So you need to run the whole thing until the last works, because everything we coded before relies on it, but the computer doesn't know. It's just a file in the computer, so you need to execute it. So how you can do that? Look, you can do. It's German again, sorry, but this one execution running something like this, and then execute all. Run all. Yeah. So okay, we're getting there, guys.
It's running. It's running.
It works for me as well.
It's working? Yeah. Okay, so again, we get the mask. So now we need one almost last function to get. So now we have like we had our geometry somewhere in space. We transformed them all to the same point and scaled them in a sense that they fit on our image frame. And now we need to transfer them into images. That's the last thing we're going to do now. And then we show samples of them, and then we are, yeah. But imagine, so what we did now, what this line does, it's a very small line, but it does a lot of work. So this goes over all the geometries and transfers them to a scale and point we need. And then we make like kind of screenshots of it. Imagine it like we don't have a window, we can see that, but now we're going to take screenshots from all of that, transfer it into images. And for that, we need another small function to take these screenshots. So we again go over all our geometries and assign the colors. So first we just find the outlines of it, and then we assign the colors we defined before. Okay, so we need this get mask. So this is like kind of the outlines that we know what's inside the geometry and what's outside. So we do this function. So we give in the geometry, we give in the shape of our image. Remember, shape of the image is like it's a quadratic, so we only need one. So we make an empty, in this case, NumPy arrow is like a tensor. What we told last time about is an empty tensor in that size. And then we take our geometries and then we iterate over them. And then for everything which is inside that, we give it a certain color, which in our case is white. So this is happening here, not finished yet. And then we return it because it's a function, right? We need to return what we did. So we assign for all of it. So 0 is like a black image. We assign a black image in the shape we give it, and then we go over it and assign white every time it's inside one of our geometries. Okay. And now we are going to use that. So just as an example, what that function did, we're just gonna use it. So we use the get mask. And then this is our new data set, right? Our first one was called DF, and now we named it here X500. So it's because it's 500 by 500 in size. It's our new data set. We're gonna use this here, put it in, and then we just want one example. So I don't know, from 10, this is the 10th, 11th image now, and then just the bedrooms because it doesn't work for all. So we need to select one, and then we give the size we want to represent it in as the shape, 500 by 500. And then we can use imshow. We also wrote it earlier, by the way, to show it. And then I have a mistake. Sorry, that's my mistake. I need to use Illustrator. So this gives me sometimes with pandas, which is basically this is pandas also, like to allocate that, to get that, we need to use illog. It's just detail. And something is still not working. Yes, I'm missing. I don't know why it didn't show it. It should show it. Yes. So this matplotlib, it should be black and white, but this function does that. So this is just the outlines of our matplib.
Error when I put len.
So okay. If you could what? This one? That means that this one was not probably not.
The capital.
No, that's, I mean, it's the same name. So I just checked if that ran basically. So just checked if the length is this, like it's still 10,000 data points. Here. So we have this other, the df is our first data frame. Then we run over each element of it and apply our getPlan method.
Okay.
And then return it. So if you want to check the length, you need to use the same name again.
Yeah, that's why I think it's because I put the X, not capital letter.
Yeah, if you do it, I mean, if this is not capital, this also needs to be not the same things. Reference. Okay. Yeah, it's gonna take a while. And then, okay, and this, by the way, I've seen people of you using it already. So the CMap, you can change colors with. For example, before, right, it was like this. Because Matplotlib is also quite a lot around for like very mathematical or like scientific representations. So it's better to have higher contrast than black and white. But so it automatically shows different colors. But if I wanted black and white, I can just add CMap. Okay. And now we're gonna see the full floor plan by using this applied. Yeah.
Nine type objective, so say. I think there's a combination. Oh, yeah. CMap, not chapters. CMap. I'm sure it's. Yeah, did you resign? Everything is. Can you check the length same as I did?
Yeah.
Which one? Must be spelling mistakes.
Okay. Does it work for most?
Mhm.
Okay. Next step, we're gonna show the whole floor plan. So did we ever use random before? That's also quite important thing. Import random is just a package to use random numbers. So So we can get an index. We're gonna create a random number now by random dot rand int. And this is, so we're gonna take a random number in like the range of our data frame, right? Our data frame is 10,000 items long. So between 0 and 1, we take a random index to show it. So how do we do that? 0 it starts from, and df, or we can also use our new name, it's called, I don't know, x 500. So in that length, we choose a random number. And the shape, as before, because we translated it in that sense, is 500 by 500. And then image is np.0. So we do a similar thing as before. We do, this is also not ideal in syntax, but okay, explain it and then we can write it the other way. So this is in the size. If you do this with the like this asterisk above, it's gonna apply for both. So it's the same as shape 0, shape 1, right? But we can, instead of this, we can use this. Okay, so I just write the other one in, comment it out. Because this is our image size, right? So shape is 500, 2 times 500, so 500 by 500 by 3 is our image. Like last time, our tensor basically we want to create. And then also we need to tell it that it's an int, so it's the D type is int, so we can use it as an image. So another loop. So now we go over all geometry columns. So over each room, take the number we assigned, the color we assigned before, and draw it on the according. We fill, so basically kind of like Photoshop, we fill each of these white blanks with these colors we iterate over. So our random index. And this is the name because we iterate over the thing we did before with all the names inside. This is and then because some of the rooms, like not all floor plans have all rooms, so then we're gonna exclude it if it's not none, because if it's none, it would break our loop. And then we use our get mask thing, right? And then we fill that, so we get the mask, so we get this black and white image, and then we assign on the part where it's 0, where it's not 0, where it's larger than 0, we use the color from our we got also above. So we have 3 lists. So one list is our colors. We created them at some point, right? Very, very far up there. We created colors for each room type. So we get that. We chose the color from that. So we go over all names from our rooms. We chose the color which is belonging to it. Then we check if this floor plan has that. And if it does have it, we draw that color, and then we can plot it. So and the CMap we take out gray because it's not a gray image anymore, right? So let's see if that works. Nope. Always not defined, why not? Maybe I called it colors. Find out. So I do this. So yeah. So go up here best and rename it color instead of colors. I think colors is occupied by something else, so we cannot use it. And then rerun it. So very far up, I get in trouble because I named where did we assign it? Here, we make our array of colors for each room. So we go over each of these names, and each of these names gets a color related to it. This is this line. And I called it earlier colors, and colors is probably occupied by one of the packages. So call it color, or we can also call it my color. I don't know. Just make it more clear, and then rerun it, please.
Rerun the whole thing.
No, only that one. That's the strength about kernels, but also sometimes the problem. So I don't. In normal code, I would have to rerun the whole. In this kernel now, I rerun this, and this is like changed. But what did I call it?
It still says error.
Wait a second. Let me check. Mm. No. Okay. Um, okay, we just do the color thing again down there, and then there's something I did something wrong with the names. Sorry, it happens. So we just maybe just go up, find that color part, and paste it there again. And we don't need to install the package every time. It's I just show you for a second. This is the color part. We only need that line actually. No, these two. We need these two lines.
Yeah, but I sorry.
Where did you get an arrow?
So just above the color.
So please just copy these two and put them at the bottom again. You find that also.
So
I don't know. Ah. Another arrow, I don't know where that is.
I think for rules.一个是好用的。是的，我这边就比如那个这边公司这个没分到那个预算会，因为我把分不进来了。对对。是的。没有，这个没事。
Okay. Let's go back to our get mouse. Something wrong with that, I guess. You guys can also do a short break. I need to fix that. We are almost there. I don't know what's the problem at the moment. Oh, okay. So I assigned somewhere, I just copied this again down here, somewhere on accident, I probably assigned geoms columns with something else. So if I correct that, that works. I don't know, there was, where that happened, but let me check. No, are not correct. Nope. Shit. Sorry for that. It's not ideal. You guys have all the same problem? Did you try it?
No, I have a different problem.
A different one.
Yeah. For image equals empty zeros, I've got some problems over there. Problems with this.
Okay, let's one after the other.
Which is on this one, yeah.
On this one,
Image equals, yeah, image equals empty but zeros.
this one,
Yeah.
this breaks already.
Sorry?
This breaks already. So it tells you, screams at you.
Raise that should be error module. Something that's no attribute. Module monthly has no attribute. You are in. Oh, I know.
The 8 is missing maybe.
No, I wrote something wrong. And now I've got a problem with it.
Now you got the same problem. Okay, I don't know. So in the code I prepared, it runs, and maybe I just restarted, but I really don't know where the problem is at the moment.
Charging. Oh yeah, I think it's charging.
So if I don't, just like I try one last run here, and if it doesn't work, I give you the one I had. I don't know. I'm sorry for that. I really don't know what the mistake is. Oh, I know what's the mistake. Oh no. Yeah, so okay guys, I know what's the mistake. I'm very sorry for that. It's very, very, very stupid. So when we chose the columns we do our transformations on, there's some too much we don't need, which are not geometries, probably this one PID. So I copy this to the, just delete, go to the geom columns. Just let me double check if that's really the mistake, but I think it should be that. So I would have had to delete this. So I copied this to the Slack and you just copied it. And you replace it first. And then we all need to rerun it, which is going to take some time. Yes, unfortunately. So replace these columns. And it's still not working. I don't know. Okay, I just share my other column with you guys. It's, I don't know why. I'm just giving up. My own is still not working. So
Yeah, something like that. No, I'm still not that here. Oh, I can run that. But it's not gonna.
yeah, for me it's the same, and I don't, I really don't know. Okay, so yeah, Okay, guys, sorry for that. Now I shared with you what I prepared actually, and we just continue with that, I guess. But so same as before, you're gonna find, I share your link. You just copy it. So I shared your link in the on Slack. And just open that and then run it until I need to shift it to the other screen.
You can change the answer to
Yeah, yeah, but you can copy it from your other from the other one, right? So there is some extra stuff, but we just run it until we reach this point. Okay, you all have that. You have the one I shared with you. I sent you.
My computer is done. And the charger doesn't
You
work.
can charge it in the back there.
Oh.
Nice also there. I think your charger is needed. This is your.
Yes. Oh, thank you.
It's running. Okay, just I'll do it like do a short break and then we just go over the next stuff very quick because sorry I wasted a lot of time that really should not have happened. Just go until you see mine's still loading. And still this is coming up. So that's basically this the function we just wrote where I somehow couldn't localize the mistake. And then this is the image we're gonna get.
Been very cool.
street,
I don't have anything to do.
which public works during the day that we.
We can just like put it on.
对，那个球也我们做的都帅气，帅气，我的帅气，逼人，在这里帅气。这两个，对，你别动了，这个这个purchase links. You getting that? Yeah. Yes.
It looks like it's here. I like updating this.
This is always interesting that with I just included to show that it's actually made of this. So this is and everything automated. You can also just be, if you have it over, that you can run all of. Just really, by the way, you can go if you click it and you shift. Yeah. The shift and shift enter. You also can run. And then yeah, now you can just go click or you know, because it jumps, you can just do this and again.
Okay. Are you guys there? Is it running until there also? Okay, so it takes some time, right? So honestly, I think the next part I wanted also to go with you, but it's very repetitive what we did before, and actually I just prepared code. So I'm just gonna explain it a little, and then we do a short, like we talk about a short presentation, and then we use Stable Diffusion, which is also all in this notebook. So, but I still wanna show that to you. So basically, because what we did here, now all the floor plans, like if we change it, if we change the index, or if we run it again, it should give us another one, but they're not all the same scale, right? Like some of them are quite small, some of them are quite large, but they're all scaled to the same size. That's not ideal. But to do it like differently would be quite complicated. So actually I have prepared that. So you can just use, that's the first thing I gave you is this Python script. So you know what you downloaded earlier, we have to reference it again from Google Colab. That's the only thing you have to do now. The rest I just show you. You can just run it along. So you can also load in Python scripts similar to as you would load in, if you load in a package from someone else, it's just a Python script someone else wrote. So we're not gonna do now that. So you reference a Python script I wrote, and then we're gonna run that to have the floor plan always in the same scale. So basically it's the same thing what we just did, but we scale it that it's always the same size to have a better machine learning model on it then. So yeah, if you find that file, the helper, so the 3 files I gave you, one is a .py file. Again, you have to do the find it on your laptop, so on your Google Drive. Ending like that. Can you find that? So you only have to replace that. That's the only thing you have to do. Found it?
But after that also the code is
Yeah, because that is not referenced. It's relying on it. Yeah, you need to locate it again on your drive. I don't, the same from this.
Drive is located for the function.
So the helper function is what you reference here. That's what so
this is loaded.
It's loaded for you. It's working. And then the next line, does that work? The import helper function. That is weird. Can you, if you open that, do you see it here? Did you delete the content in the end? Then no sort of you need to find it in your drive, in your like your where you located it. So I shared with you 3 files, right?
This is the place I located.
Then it must something must be wrong.
Because it's the same thing I'm using here.
Something with the plugins.
Same location.
Yeah,
I'm using the same location for this also.
but then looking in the drive, maybe the helper is not there, something like that.
Running complex here.
Last 2. Helper is not there.
Yeah.
Okay, guys, so
No,
it's not working.
Yes, working.
Working, okay. Just need to locate it. It needs to be same as always, needs to be the same up and like if it's capital or small. I just, okay, differently. I just show you what it does and you look at it at home. But this, the only thing you need to change to make it run is you need to find also for you at home, you need to find a path to this Python function. I shared it with you, but you need to find that, okay? If you find it now, optimal. If not, find it at home, because we need that data. This is going to be part of the exercise also. So we mount it again. If we import it like that, it's going to show up here on the right side. On this side, we loaded this function. We use this. We have here our .python file. It's like a Python file, and then you can reference it like this because it's located here. Import, same as all other packages. It's the short version of it, and then you can use it, right? So this is basically similar thing as you did before. So here I find the diagonal for all of it, then I use it, and now because we just do it smaller, 128 by 128, because the machine learning model we're going to train is quite small. To have a better start, we start small. So we do basically the same thing, and then it's going to output us images which are always centered and always in the same scale. Some of them are large, some of them are small, but they are always in the same scale, unlike what we had before. So you don't need that now, but we need that for the homework. Is going to be part of it, because what I didn't provide you, you basically have everything, but what I didn't provide you is to save these images in your drive. So we need the 10,000 images from each of the rows saved in our drive, and then I want to extract you extra data, and that's I'm going to show you that now in a second. So still running. But basically, this is the code we wrote before with the larger one. It's just a different size. We're going to create images. And then here, for example, I also show sizes of it. And I'm going to send you a commented file again. Here you show 3 at the same time, for example. So we need a loop to get the 10,000 images out in our drive folder. So yeah, it's also working. Right. If you reference, the only thing you need to do is exchange your path to the Python function, and then you can just run it. This is gonna take time again, this one, and then we can export it, right? And we show 3 random, and now they are like, for example, before this one would have been scaled to the whole size. We don't want that, right? Because it's not the real scale of it. So it's the only thing I added and reference. And now we're gonna do a very, very, very short presentation, hopefully. You need a break. You want a break?
you just need to find an RFM.
Still not. Yeah, but for you, it's working now. You found it okay. So general it works.
Oh, it just breaks between. Okay, there's a space in the folder that or there's a space in the name of the folder I named.
That might
And then in this
be-
case, while I'm trying to reference it, it just breaks into two parts.
Yeah, every letter needs to be correct.
So, but the original name does have a. It does have a space between. You know what?
Yeah.
About.
Okay, a little bit of superficial theory. So we talked a little bit about neural networks before, right? And what we're gonna train next time and what Stable Diffusion is, Midjourney is called a diffusion model or a diffuser, DDPM, several names for it. So that's what we're gonna do next time. We have now more or less a very large data set. I'm gonna provide that to you also in the worst case, but I still want you to extract that data. Hopefully can manage, ask me questions in advance if you can't. And we're gonna train a model on that, and we can. So last time we had that like tensors, right? Images are tensors. Everyone remembers. So there's one other concept. All the math is not that important, but I just want to mention it. So there's something called convolutions, which basically you go over an image, you just extract features of it, so parts of it, condense it, you condense it, and then you train the model on it. That's called a convolutional neural network. And that's if you do that if you work with images. And the most important about that is that it has a spatial knowledge, right? So it gives you an idea about certain features in a spatial context. That's why that's important for us. And it's not limited to images, but it's specialized on recognizing spatial patterns. So you can do a 1D, like a vector also, a 1D line of data. You can train a model on that, but it's not gonna, you can, in theory, even condense your spatial data. You could take an image, take each slide, make it in a long row, but the image won't, like the neural network won't understand the spatiality of it. So it's not limited to image data, but it needs to be grid-based data, basically. For example, this is also grid-based data, right? Quickly a 2D tensor. Each point, in fact, so you could save the length and the rotation. That would be a 2D, like a 3D tensor, but with only two depths instead of red, green, blue. You could have the rotation and the direction. Or in this one, it could be also discrete, or there's a lot of possibilities to do, for example, vector fields with it. But the thing is, it's a spatial thing. It can also be 3D, but a convolutional neural network, and what we are doing is convolutional, always works better if it's based on a spatial configuration than if you put it in a long row. For example, if you have some of you guys are doing, if you have like elements, and you start, it's really like a row. So it's an element, there's another element added to a vector, like in a certain rotation, you could use that. But as soon as it becomes spatial in any sense, you should use convolutions and not 1D, but 2D or 3D data. So and a diffusion model very, very basically functions like that. So you take an image, the guy on the right side, and you add noise to it. You have like 100 steps where you add noise. And because you know always, it's easy to say, like to calculate if you add noise. So you need also you can predict that the other way around. So you train the model to predict the noise you would add, and then you reverse the process. Imagine you have an image and you add noise, and your neural network is trained to predict how the noise looks you add. And then if you use the model, you predict the noise, but you subtract it. So you go backwards. So you start from a noisy image, and you predict which was the noise that was added to that, and then you subtract it. And you do this 100 times, 1,000 times, and then it creates a real image again. This is the magic of the diffusion model. So you train it to predict noise, and then you subtract that noise, and then it becomes magically a clear image again. This is basically how diffusion models roughly work. And then there's some more fancy things to it. So we're gonna train a quite basic diffusion model, right? But something like Stable Diffusion, of course, is like text encoding. So it's called conditioned. It's conditioned on text. So that's why if you put in text, it's gonna give you an image which is relating to that, right? It looks similar somehow. And it's because you have a very, very large text encoding. So you train it based, like the images have text descriptions, and you train it to learn that parallel to the noising. So it denoises in a space which is calculated relating on that text. It's conditional modeling. And this is a other representation of it. It's quite complex. We don't need to go in depth. If someone is interested, I sent you a video about it, but you really don't have to watch it for what we are doing. It's just extra information. So then conditioning. So what I said here, yeah, text conditioning, right? We know that from Stable Diffusion, Midjourney or something, but we can also condition on other things. And that's also something I really want to have you thinking about. So you've seen the data set we had, right? So there's some ideas of conditioning I just give you, which is not text, but it's just a tensor, another tensor, a number. So for example, if we just take the image as an outline like this, right, and calculate the size of the black space, of the white space, we know the relative size of it. That could be an input as a single number. And ideally, we would always normalize it. It's called, I show you also how to do it. So we put it in the range between 0 and 1. Not, we don't, if it's like, if what we get back is like 64 or 800, we don't care. We take from smallest to the largest and put it in the range of 0 to 1. But it would be a very simple conditioning. So what that would mean, if I had a model conditioned like this, successfully conditioned like this, I give it a number of a certain size and it gives me a floor plan in that size, So that's might be the aim. Another one is how many rooms it has, right? So if I look at a floor plan like this, I could make it in a 1D conditional tensor. I could condition it on that. So if I give it something in the shape of this, it would give me ideally a floor plan like this. If I give it a 2 instead of the 3, then it would give me something with only 2 bedrooms instead of 3. It's the other way of conditioning. So, and then, for example, if the floor plan wouldn't have a balcony, this one would be a 0. The balcony would be 0. So that's also a way of conditioning. And then most advanced complex, we looked at this last time, is this graphs, right? Also a way of conditioning. Is that roughly understood the concept of conditioning? So if we train on our floor plans and we give data that looks like either like this is just a single number or like a range of these numbers, a range of these, and we have a data set where we know of each of these floor plans also the according number. So we have 10,000 floor plans, right? And for each of them, we know, oh, it has 1 bedroom, 2 bedrooms, 5 bedrooms. So we can extract that for each of them and then condition our model on that. This is the rough idea of a conditional diffuser. If we don't use text, and we won't use text, in theory possible, but then things become way, way, way more complicated. So that's something you don't have to do it for the whole data set, but I would like to think you as a homework or like try it for at least one of the data points to extract a tensor like this. So choose one of the 3. This is probably the easiest. I write you an email again, or like where I list it, where you find like one of the things you can extract from the data set we had that we can condition on it. So one of the 3. So either which rooms it contains, how large it is, or how is this connectivity matrix. Okay. Questions? No?
Slides.
I will. I forgot last time. I share all 3.
Do it again.
So the basic things you need to take from that is only convolutions work spatially. So the model we train is a convolutional model. So it works on data which is spatial. An image is spatial, right? It's like in 2D space. Or a 3D object like 3D cubes is also spatial. On these that works. on data which is not coherently spatial in a grid, it won't work. So if we have data which is also in space but dispersed, this kind of model won't work, like not in a grid kind oriented. That's the first thing. And the second thing is roughly a diffusion model works in a way that we train it. We start with a very large data set of clear images. We add noise and we train the model to predict how the noise we add will look. And then we will use it the other way around. So we take noise, we let it predict which noise was added, and then we subtract that noise. It's the rough idea. But as users, as we will do it, we don't need that in depth. I just tell you once, because I think it's good to have an idea what is like a neural network actually capable of, kind of. Okay. And now we look at Stable Diffusion. I don't know, does any one of you has used it already, Stable Diffusion or Midjourney? Yeah, Stable Diffusion as well. Yeah. So we just, with the code I gave you earlier, we just look at it very quickly. And it's anyways, it's a so-called API. So it's not really coding, it's other people provide that information, we just use it. But I just want to show you once. So maybe still, if you want to code it along, or it doesn't matter, maybe it doesn't matter. So Torch, we used that before for our tensors, right? This is basically our main machine learning library. And this is CUDA available, checks if we have a GPU on our computer, which is working. Because we are on Colab, doesn't matter, we all have it. But we need a GPU for machine learning because we need a lot of computational power. So that we need to check if it's available. And then by this, for example, we can ask which GPU we got. So probably I just restart this because I need to. So yeah, first thing, we need to change the running time to GPU. If you go on runtime, change runtime, and then probably yours is probably on GPU, on CPU, but we need the T4 GPU. Okay. So if you have that do you have the notebook open I sent you? Yeah, please do that, change it to GPU and then save. Did you all do it? So it needs, because I shared it with you, okay. So then if we do this, can you execute it as well? This should say true. It's important. That's how we check if our GPU is running. And this will give us information about our GPU. So this, for example, is a Tesla T4. If you had paid for Google Colab Pro, they're gonna give you better and quicker GPUs. So now we just install. This line of code is a pre-trained installation. So this is libraries we need. Here they are listed: diffusers, transformers, accelerate, invisible watermark, and this MediaPy. This is the things we need to run our stable pre-trained stable diffusion model. And then this basically downloads it. So we make a pipeline. Next time we're gonna make it with our own model. So we download a pipeline with a pre-trained here from pre-trained, and then we just call it the name. It's already part of the pipeline. It's downloaded. This is the download thing. So it's very handy, very nicely done for us. It's downloading the stuff. And there's things we need to specify. For example, use safe tensors is that it's the model which is trained to include no graphic things, no pornography, no violence. It's all like the variant is FP16 is smaller, FP32 is larger, like that. And then here, this is important we put it on our GPU. But as you may have noticed, you don't need to know all that stuff. I'm gonna give you the collabs and you only need to edit what you do different, you know? Did you execute it as well? So downloading. Did you restart the code? Because if you ran the code before, I should have said that earlier, sorry. Maybe there's probably not enough capacity on the GPU, so you may have to like restart it because otherwise it will complain it can't generate an image because there's not enough space. But just try it. Really.
I can like put my file here, the one in the drive. I don't know why it doesn't work.
Which file?
The
one I shared?
the helper functions one.
You still need on the
Like I downloaded again, but it doesn't work. It's just an indication file. Yeah, it's there.
Can you show me the
It's sample images in my drive and the file. And I downloaded it in my I don't know what to do.
we need to include slash content after the again, but I'm not sure. And the backspace. And there must be a space
Here.
after the dot time. Yeah. No, this is. I don't get it. You have to send probably for.
What should I do?
You need to check it again. I don't know. It must be. I don't know why it doesn't. There's maybe there ones where needs to. Do you need? Oh, then let me check. It's really slow. So it's very large files, as you can see, by the way. This one is 5 GB, so that's why it's so slow. Here you can see it. Okay. So you have content drive, my drive. It's all there.
Yes. Oh, content, but yeah, I have it.
Are you logged in to the Google Drive?
Yeah, in Colab. It doesn't matter that it's in another language, right?
Hmm?
It doesn't matter that it's in another language. Like,
It shouldn't. It shouldn't. No. Also, before first it didn't work, it didn't work right. So
in the other,
I think the downloading it doesn't make sense that it would change it. You know, it feels random. Let me put that like. Mine is finished. It's yours.
Yeah.
Yeah. So now this is, we just do a very, 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 very short inference. So number of images, I think we only can do 1 because our graphic card is too small to do more. But in theory, we could do 5 at the same time or 3. And then this is our prompt. And this is our seed. You can either this seed, if you use this one, it's a random one, just completely random. Seed means it's like a random number, and if you give different seeds, it's gonna give different images. If you give it the same seed, it should do the same image, and we're gonna find that out now. And then you can give negative prompts as well. So the things you don't like, you wanted to exclude, please stray the first away from, so you can. And if you use, you can put way more stuff into Stable Diffusion even, but that's a field for itself. So just gonna do a very basic one. This Stable Diffusion extra large, by the way, so XL. It's the large, quite recent one. So we can run that, and then here I get the image. So this is, if I put it in the pipeline, it's gonna create one. Probably also gonna quite small, quite slow. So can you just run it yourself? Try a prompt, whatever you want. Better do the random seed, so comment that out, and that in.
Yeah. Perfect ending.
Got a different one with the same
Change the
seed. Yeah, that's good. That's how it should be.
change instead of using the top one, use the learning one.
So I got the same because I got the same seed. Now so we're gonna do another one. Did it work for everyone? Everyone has a beautiful Stable Diffusion XL image. More or less beautiful.
I'll just take that line.
It does take that long because the GPU we get for free from Google is not that great. Probably the one most of you have really like gaming laptop. Probably you may have better GPUs locally than they provide. And also, if you use it too much, like if you use Colab on GPUs a lot, it's gonna not allow you to use more GPU power. So yeah, except you pay for it. So there's like a cap on it that way. Yeah, my second one is even way smaller than the first. I don't know why. So of course it's a very, very, very well-trained model. The one we're gonna train next time won't be even close to that sophisticated, but it's on our own data and our own conditioning. That's the more important part. And also this thing that we do, that we can condition other data than text, and that we can use it for other data than images. It needs to be spatial, but yeah, as said, vectors, for example, rotations.
Five for non-memorized, it will take long time, right?
It will take longer, and also it may break because the thing is, if you do that, something like that, if you do inference is called, you ask a model to produce something. If you do that, you need to shift data from your local machine, from your CPU to your GPU, and your GPU, the RAM power is basically that, how many GB does it has, and since these are not so good, they may run out of that. But this can't be this because it's somewhere in a server, probably in, I don't know, a server somewhere. Okay, this is my other image. Just stack blocks. Okay.
You go.
Sorry.
So the only thing, so did you, this part, I really brushed over it. Did something, so basically, you just need to redo that if you manage to link it. And then just run it. And then I want you to save all of these images. So just write a loop which goes over all the 10,000 images and save them in a folder on your Google Drive that we can use them next time for training. And yeah, I give you a few more exercises. I can write your work. And about all this transformation stuff, so like how we rotate and all, like this part, basically the get plan, that's more, just be aware that you can do these kind of operations also with Python. You can maybe use it for Grasshopper, in Grasshopper if you want to, stuff like that, but you don't need to, you don't need to do this. We won't do this again, but it's just basic stuff like that. You can have, like you can write functions which do operations very generally, but you don't need to learn the syntax of that basically. So you don't need to know that, I don't know, like, I don't know, the inner dot centroid, the syntax, how to find a centroid, you don't, just not important. Okay.
To generate the images, you can generate multiple images together, right?
You can.
Like you did here. Yeah.
But the thing is, you can, so this one are just picks, they're not generated, right? We picked them from our data set. We didn't train yet, we need to train. And here you can generate several, but as said, probably eventually the capacity of the GPU from Drive is too small, because also Stable Diffusion XL, look, like also you see the scale, it's like 1024 by 1024, so it's quite large. It's not really large, but if you put it on a GPU, it adds up quite quick. And also, because otherwise we couldn't use the GPU, our model is on the GPU already, and our model is like 6 GB or something like that. So the model we downloaded, so not the Stable Diffusion. Look, we do that here. To CUDA. So CUDA is type to CUDA means we put it on the GPU. And it has, the pipeline probably has, I don't know, 6, 7, 8 gigabytes. So these are already occupied. We probably only have like 12 or something. So yeah, that runs out of capacity quite quickly on Colab. But it doesn't matter, like when we train on only 128 by 128, so quite small images, and there it's not important. So yeah. Any questions? Any concerns? Any? Do you guys have any idea how to some degree maybe apply that to something else you guys are doing? No. I kind of thought so. Keep thinking about it. Thing is, for example, what you could think about, if you generate data by what you are doing, you can train on that data. Or if you use this, whatever, this floor plan data, and then you use your other system, which is building around, maybe you like use that to not build your system there, because you know, like how you can also connect it the other way. You can maybe train it on the floor plans and then do your system in a generative way, but it doesn't generate where the rooms are, quote unquote. So you don't need to necessarily make data for it, but you can either make data from your project and train on it, or you can use the train stuff and make your project react to it. Both might be legit. Yeah, that's what I thought. That's what.
How do we solve that?
If you do, so one image works, 5 don't work. You can, there's links for the small Stable Diffusion for the 512 by 512. There you can maybe do several. It's a limitation of basically of Colab. So because the GPU is not that strong, so this you cannot solve it, except you pay for Google Pro, but I'm not advising that. That's open. Or you run it locally, everything we code, you can run it locally, but you need to install the packages also.
Yeah,
So
that is easy, right?
sometimes it's more tedious than you may think, but in general, yes. So, for example, for the training, you can think about installing it
All the
locally. I can
packages
help
that we
you.
imported, we can install for Visual Script.
Hmm?
All the Visual Code, right? All the packages that we
Yeah,
imported.
it's the only thing is if you install it locally, it is you have to more look that the package versions are matching. This is something in Colab. That's why I use Colab with you guys, because there's not time we want to use. So sorry for the long wait today. That wasn't planned. What was your presentation last week? Good.